by string, and this atom for the vibrational mode will follow Hooke's law. According to Hooke's law, force is directly proportional to x, where x is the displacement, and it can be written as F is equal to minus kx, where k is the spring constant. So for mathematical derivation, if we consider this as the nth atom, along the right side this is n plus 1, this is n plus 2, and this is n minus 1. The left hand side, this is n minus 2 atom. So if these atoms are in vibrational mode, this atom if these atoms vibrate, so they will exert force on each other and will be displaced by some distance. So if this nth atom displaced by magnitude xn along the right side, this by xn plus 1. Similarly, if this atom exert force on each other, then n minus nth atom will displace by x n minus 1. Similarly, x n minus 2. So we will firstly find out the force, net force exerted by the neighboring atoms on the nth atom. So it will be like if I consider the case of these two atoms, then force is equal to, if I write it, F is equal to beta x. Beta is the constant, beta x, where x is the displacement. For the this case, displacement will be, net displacement will be xn plus 1 minus xn. So force in this will be beta, displacement is xn plus 1 minus xn. In this case, I am considering the force exerted on the xn atom by xn plus 1. Similarly, if on the left hand side I have atom n minus 1th atom, so it will also exert force on this xn atom. So if I am taking this direction as positive and this as negative, so the force on the nth atom, this is the force 1 and this is the force 2 by the n minus 1th atom. So it will be beta x n minus 1 minus xn, because the direction you can I am considering this factor as like the nth atom is displaced along this direction, and this is along 1 second. F2 force is equal to beta, F2 force is equal to beta xn minus 1 minus xn. So total force is equal to beta F1 plus F2. F is equal to F1 plus F2. Beta is equal to xn plus 1 minus xn plus beta xn minus 1 minus xn. So F will be equal to beta xn plus 1 plus xn minus 1 minus 2xn. If the solution of this xn is a e raised to power iota omega t minus k n a, where Na is the distance of nth atom from the center. If you're considering some atom as the reference point at you can say at the origin, so and the distance between two neighboring atom is a, so for the nth atom it will be equal to Na. So xn will be equal to, if the solution, if the we will write if the solution of this equation is xn is equal to this, so we will solve it for xn. F is equal to ma, where a is the acceleration, so f can be written as d square xn divided by dt square. So the equation, this equation will become equal to m d square x by dt square is equal to beta xn plus 1 xn minus 1 minus 2 xn. So by taking first order derivative and second order derivative of this xn, and then by putting the value of this dx by dt and d square xn by dt square in this equation, we will have like xn is equal to a e raised to power iota omega t minus kna. Similarly, it will be for xn minus a e raised to power iota omega t, n will be replaced by n minus a into a, and for n plus 1 it will be a e raised to power iota omega t minus k n plus 1 into a. So dxn by dt will be equal to a e raised to power iota omega t minus kna dot derivative of this with the t will be equal to iota omega, and second derivative will be equal to a e raised to power iota omega t minus kna into iota omega. So iota square will be equal to minus 1, it will be minus is omega square raised to power iota omega t minus kna. So by putting the value of this and these four values in the equation m d square x and by dt square is equal to beta xn plus 1 plus xn minus 1 minus 2 xn. So we will have at the final minus m omega square e raised to power iota ka plus e raised to power minus iota k minus 2. So by dividing this equation by 2, taking common 2 beta e raised to power iota ka plus e raised to power minus iota k divided by 2 minus 1, 2 beta as e raised to power iota theta plus e raised to power minus iota theta divided by 2 is cos theta. So we can write it this equation in term of cos beta, 2 beta cos ka divided by 2 minus 1, taking common minus negative sign common, minus 2 beta 1 minus cos ka minus 2 beta. Here it is minus sign, also on the left hand side minus, so minus will balance out. M omega square is equal to 2 beta 1 minus cos ka. It will be 2 beta 1 minus cos theta is 2 sin square theta by 2. So m omega square is equal to 2 to the 4 beta sin square ka by 2. Omega square is equal to 4 beta by m sine square k by 2 omega is equal to plus minus twice of under the root beta by m sine k by 2. So this is the frequency with which this atom vibrate, or we can say lattice vibrate, or atom vibrate in the lattice. So omega is equal to plus minus 2 beta by m under the root sine square k by 2. So we can write it in the term of phase velocity and quick velocity. The next step is, if I am considering C as the stiffness and rho as the linear density, which can be termed as rho is equal to mass, density is mass per unit volume, but I am here, that was volume density, but here it is linear density, so it will be mass per unit distance, because it is linear density. So C is equal to force by strain, and strain, as you know very well, strain is equal to change in length divided by original length. So change in length divided by original length. So C is equal to F divided by this change in length, that was the displacement with which the atom displaced, the amount that was x, and original length is a. So C is equal to AF divided by x, or C by A is equal to Fx. And also F is equal to minus Kx, or F is equal to, if I am considering this as beta, so F by x is equal to beta. So by putting the value of this C in the equation omega, it is 2 beta by m sine Ka by 2 twice of, this is beta, and beta is equal to C by A, and m in the term of linear density is m. Rho is equal to mass per unit. C is equal to beta A. C is equal to beta A. So C is equal to beta A, and beta is equal to C by A into mass. The value of mass is equal to rho A. So sine Ka by 2. Beta divided by m, it is m, so rho A, it is beta. Beta is equal to, when we put the value of this is equal to omega is equal to 2 by, sorry, where it is, m is equal to rho A, so it will be a square, so it will be out of this under the root sign, and it will be equal to A C by rho into sine K by 2. So the final velocity in the term of, and C by rho can be written as velocity, which is the velocity of sound in solid. So final frequency is equal to 2 by A under the root C by rho sine Ka by 2. So for the lower frequency case, if the frequency is low, so the wavelength is inversely proportional to the frequency, so wavelength will be higher wavelength, it will be equal to, if I am considering this factor sine Ka by 2, also K is equal to 2 pi by lambda. So for the higher wavelength, it is in the denominator, so if for the higher wavelength it will be lesser than equal. So sine for theta less than 1 and sine theta is equal to theta. Sine theta will become equal to theta for theta less than 1 for the higher wavelength case. So omega will be equal to 2 by a, and this is v0 velocity into ka by 2, because here in this case theta is equal to k by 2. So by cancelling this a and 2, omega is equal to v naught k. So as we know, there are two types of velocity: phase velocity and the group velocity. Group velocity is the velocity with which the wave packet move, and the phase velocity is the velocity of the point or with which it advanced in the forward direction, in the propagation direction. So phase velocity is equal to omega by k. Vp is equal to omega by k. In this if I divide here omega with k, it is equal to v naught. So phase velocity is equal to v naught. Group velocity is equal to d omega by dk. Group velocity is equal to d omega by dk. So if I take differentiation of this omega and k, so omega is equal to v naught k. So d omega is equal to v naught into dk. If I am taking differentiation to both the side, d omega by dk is equal to v naught, where d omega by dk is equal to group velocity. So group velocity here it is equal to v naught. So what we see here, group velocity and phase velocity are equal for the lower value of frequency. Similarly, if we go for higher frequency, in this case what we will do for the case of higher frequency, what we will do as omega is equal to 2 by a v naught sine ka by 2. Also phase velocity was equal to omega by k, so it will be 2 by a v naught divided by k sine ka by 2. So what we will see here, this ka by 2 and this factor, you can write vp is equal to v naught sine ka by 2 divided by ka by 2. If I am writing it as like this ka by 2, so vp is equal to v naught when this k tends to 0. What I do here, for the higher frequency, for the case of higher frequency, I am writing the equation of this like v naught sine ka by 2 and it in the denominator side. And when I take a condition that when k tends to 0, so sine theta divided by theta, and limit is theta tend to 0. So this you know it very well as you do it in the mathematics. Limit, when I put limit theta tends to 0, sine theta divided by theta will become equal to 1. So vp is equal to, this whole factor will become equal to 1. So vp will become equal to v0. Similarly, when we go for vg, that was equal to d omega by dk, so it will be, when I am taking differentiation of this d omega by dk, 2 by a v naught sine theta, differentiation of sine theta is equal to cos theta, and the differentiation of this angle with ka by 2. So here it will be equal to 1. So vg equal to v naught cos ka by 2. So when I'm putting k tends to 0. So for the lower value of k tends to 0, cos 0 will become equal to 1 when I'm taking it equal to nearly equal to 0. So cos 0, the value of cos 0 is 1, so vc equal to v naught. So here we what I can say here, the value of group velocity and phase velocity is equal. Value of group velocity and phase velocity is equal if I am implementing the condition that case tends to 0 for the case of higher frequency. Similarly, if I do lattice vibration for diatomic molecule, lattice vibration for diatomic molecule. For the last topic, it was for the monoatomic single atom, but if I am considering a NaCl crystal, here the atom are of sodium and second one is of chlorine, so it will form a diatomic molecule. So vibration of one dimensional diatomic lattice will be studied as. Similarly, if the two atoms of mass small m, if I am taking two atoms of mass small m and capital M, and place these atoms small m at even number and capital M at odd number, that is even numbered point and it is odd numbered point. So the location of these all the atoms in the lattice will be like the point of vibration will be same for like these are attached with a spring of spring constant k, and the force exerted by the neighboring atom will be countable if the distance between the reference atom and the exerting atom is small. So if this is the 2n atom, this is 2n plus 1, this is 2n plus 2, this is 2n minus 1, this is 2n minus 2 atom. So the this if there is vibration in this lattice, if there is vibration in the lattice, the displacement will be equal to x2n